Alright, welcome back. We're looking at problem number 7, using the activity series to predict whether the following reactions will occur. So all of these reactions, A, B, C, and D, are single replacement reactions. And in these single replacement reactions, all 4 of them involve metal-metal replacements. Since the lone element is a metal, we know the only thing that it could swap with, if it's going to happen, is the metal in the first position of the compound. So copper, sodium, lithium, and aluminum. Those are our candidates for swapping. Alright, so let's look at the first reaction. Copper 2 chloride plus aluminum. Well, how can we tell if aluminum is reactive enough to displace the copper from the compound? It's actually really easy. We look in our reference tables at page 7, and we look for our 2 elements. So we have copper in the compound and aluminum trying to replace it. So here's aluminum, and all the way down here is copper. It's barely on the screen. Copper is less reactive than aluminum. So aluminum will replace copper in a compound. So if we come over here, aluminum will knock the copper out of the compound and form a compound between itself and chlorine. So Al and Cl. We do our swap and drop. Chlorine is a -1, aluminum is a +3. Therefore, 3 chlorides are required to balance out the 1 aluminum. The element by itself now is copper. And then we just go through and balance. I'm not going to work through those steps because you can do that. So it's 3, 2, 2, and 3. Second reaction, sodium nitrate reacts with zinc metal to produce something. Well, if it's going to happen, zinc will team up with nitrate, and sodium would be knocked off by itself. Let's check our reference tables, and sodium is way up here in the category that will replace hydrogen from cold water, meaning it would actually start to react with water if you just dropped a piece in. And the other metal we're looking for was zinc, so we come down, and zinc is down here. It'll replace hydrogen from steam, but not from cold water. So zinc and sodium. Sodium will replace zinc. Zinc cannot replace sodium because sodium is more reactive. So this is a no reaction. Okay? If it went forward and zinc made a compound with the nitrate and sodium was left by itself, the reverse reaction, sodium displacing zinc, happens much faster. And so it effectively does not happen at all. Lithium chloride plus silver metal. Well, again, we look for lithium. It's all the way at the top of the activity series. So just for kicks and giggles, we can look for our silver, and it's going down, going down, going down, and oh, here it is. It's all the way at the bottom because it's almost totally inert. Only platinum and gold are less reactive. So, this reaction is never going to happen. Last reaction, potassium reacts with aluminum sulfate. Well, will potassium be reactive enough to displace aluminum? Let's see. Potassium, third one down from the top. That's extremely reactive, and since it's not one of the elements above it, or aluminum is not above it, we know that potassium will displace the aluminum. So we write potassium with the sulfate ions, okay, then SO4. We check our oxidations, +1, -2. So swap and drop tells me I need 2 potassiums for every 1 sulfate. And it will also produce some aluminum metal because aluminum has been kicked out of the compound. Then we just balance this equation, and we need 6 potassiums, 3 potassium sulfates, and 2 aluminums. And we can go ahead and write a 1. Oops, there we go. A 1 for the aluminum sulfates going in. And that reaction is now balanced. Tune in for another video for problem number 8.